USC Boulder, then went back to New York and studied there. I want to thank, first and foremost, Wonderbound for hosting us here in the space. Their work is tremendous. I love dance personally. I have a personal connection with it. To me, dance is the physical body and musical motion, so it's beautiful the work they do here. And thank you to Wonderbound, to Amy, to Hidary, to the whole team. Also to Brett, who's working the video and helping out with all logistics here tonight. Thank you, Brett. And I'd like to give a special thanks to my dear friend Michelle, who without this all would not be possible. Her and Mike have sponsored this night, and it's just really warms my heart. Thank you very much. I'd also like to thank Ali Shanti for helping bring this incredible audience together. Ali's here. Thank you, Ali. And Monique Elwell is also here. It's actually Monique's birthday tonight, so special shout out. It's your party. We're all here for you. And so I also want to give a thanks to Steinway for this piano's not always here. I want to thank my friends at Steinway and Schmidt Music here in Denver for providing Steinway for this performance tonight. So it's a real treat to play a piano like this. It was actually came directly from the Denver Symphony Hall today. So we get to borrow for the night. So thank you to Gary from Schmidt Music and Steinway. Before I begin playing, and we'll be together here for about an hour, just for those that did reservations or something after. So we'll be together here for about an hour. And of course, everyone's welcome to continue drinking and socializing afterwards. Before I begin playing, I'd like to share some of my thoughts about what informs the music you'll hear tonight and the work that I do. And I'd like to start with this guy, Einstein. Einstein taught us that the past, present, and future are all illusions, albeit stubborn ones, albeit persistent ones. What did he mean by that? What was he getting at with that statement? Well, back over 100 years ago, he had a thought experiment. And as a physicist, one of the greatest creative minds in human history, he was famous for his thought experiments, which would allow him to just really rethink the way the universe works. And this particular thought experiment, dating back to just before 1905, allowed him to revolutionize the way we think about the universe. But what was his thought experiment? He imagined himself on a train. This train would be stationary. He would have a flashlight. Shine the flashlight up to the ceiling. There would be a mirror on the ceiling. The light would go up. The light would come down. And he wanted to know what would the light look like if you were sitting on that stationary train. And so the light would go up, the light would come down. I think you can all envision, common sense, what that light would look like. It makes normal sense. In the same way that if you were on an airplane, sitting at the gate, and you were waiting for the airplane to take off, you took a ball, you threw it up in the air, it would land back in your lap. I think we'd all agree that makes a lot of sense, and nothing really breakthrough about that. Well, then he took it a step further. And he said, what if this train were moving? What if the train were moving? Now, if you're on the train, and you shine a light up, and it comes back down, same thing would be experienced. You'd see the light go up, see the light come down. In the same way that if you're on that airplane, and now you're traveling from New York to Denver, you throw the ball up, it lands back in your lap. Makes perfect sense. And here's where his thought experiment kind of jumped to the next level. He said, what if there was someone who is not on the train, standing on the embankment, looking at the train, and watching Einstein shine this light up to the mirror? What would the light look like for the person standing stationary on the embankment? And what Einstein surmised was that it would look like this shape, a triangular shape, a bent shape. And that is very different than what it would look like if you were on the train. Now, why does that matter? Well, that matters because the actual distance the light must travel in both cases is different. You see here the top line is the light distance traveled in the first experiment from that frame. In the bottom line, it's longer, and that is the distance the light would travel in the second frame from the person's viewpoint on the ground watching the train. Now, in pre-Einsteinian physics, this would be simply explained that the light just sped up in this example, in the second example, to catch up. And in the same way that if I was on that airplane and I throw the ball up and I catch it, and for me it looks like it's going up and down, if somebody on the ground was looking up at the plane watching it, they would actually see the ball move in this spark-like shape. And indeed, actually, in the case of the plane, from the person's vantage point on the ground, that ball actually is moving faster. However, in the case of light, Einstein taught us that light cannot travel faster than 186,000 miles per second. Light is a constant. It does not slow down. It cannot speed up. Therefore, how can we explain the fact that both of these observers are looking at the same thing, but in one case, light travels further, and it can't be sped up? Something has to give. And in this case, time itself is what gives. And that was the breakthrough of Einstein's special relativity. He called it time dilation, the stretching of time, the elasticity of time. If these two people, one on the train, one off the train, were to start their watches at the same time, and then get off when the guy gets off the train, they compare watches, one will be different than the other by the precise calculation that Einstein came up with. Pretty remarkable and revolutionary. Well, you might say, that's great, pretty incredible. What does this have anything to do with music? Didn't I come here to listen to music tonight? Well, I'm glad you asked. Imagine we have our same stationary observer on the ground on Earth, and we have one guy in a rocket ship traveling at half the speed of light, listening to a piece of music. To him, that music sounds wrong. He's listening to the Beatles song, sounds great. If he were to beam that down to our little friend there on Earth, that beam of radio transmissions traveling at the speed of light, and our stationary observer would actually hear a different piece of music because of Einstein's time dilation. If we had a second spaceship traveler, and she was in her rocket ship playing the same song, started at the same exact time as our first rocket ship friend, she would hear it normal in her headphones, in her rocket ship. If she were to beam that over to rocket ship 1, if she were to beam that down to Earth, to our stationary observer, both would hear two completely different songs. Time dilation. And so this phenomenon, while as much as I'd love to take everyone in this room, put us on a spaceship and travel at near the speed of light to experience this, unfortunately for now, we'll have to resort to another means. And so at the piano, I have employed certain techniques. With one hand of the piano, I will mimic what Spaceship 1 might experience. With the other hand, what Spaceship 2 might experience. And all of us here in the audience are the stationary observers on Earth, experiencing it from two different vantage points. Quantum physics. But we're getting off of just relativity. Werner Heisenberg, German physicist, 1930s, starts talking about this notion that our entire universe, our existence, has this element of uncertainty to it. Complete uncertainty. Like, really. That's the way it's engineered. What do I mean by that? Well, I'm sure most of you have heard of Heisenberg's uncertainty principle. Heisenberg's uncertainty principle basically says the following. Well, what's uncertain? What's uncertain? What is uncertain? Well, he said that if we know the identity of something, the position of something, something is here, I know where it is, I can pinpoint it, then I have no way of knowing how it got there, how fast it's going, its momentum, its speed, its velocity, I have no idea. If I know inversely its velocity, its speed, its movement, I have no idea didn't it? We've got 3 electrons spinning around a nucleus, in this case a lithium atom. Turns out, totally wrong. Totally not true. According to quantum physics, it looks more like what the picture is on the right. This cloud-like electronness, it exists in all places at once. There is no certain position that it exists until it is observed through some means, through some measurement. And then we can pinpoint its location, we don't know its speed, and then it goes back into this electronness. Physicists call this the wave function, quantum wave function. And it looks like this on the bottom right. It looks like a wave, you can imagine that. It's important when you look at this to imagine it not in 2 dimensions, but in 3 dimensions. Right? On the top right, this cloud-like yellowness is in 3 dimensions. It's electronness around the nucleus of this atom. And so when we observe it, it collapses down into a narrow field in which we can pinpoint its location, and then afterwards it expands back out into uncertainty. That is the notion of a wave function. Some places are more probable than others. It's not equally probable that it'll be everywhere. It's more probable in some places, less probable in others. Well, Murray, what does this have anything to do with music? We just said that if we know its momentum, we can't know its identity, its position, and vice versa. Well, what in music is identity? Identity in music is the key of C, key of D, key of F sharp. That's identity in music. And I can play that, and you can very clearly distinguish that. But there's no speed or velocity really to it. It just kind of is. And the longer I hold it, imagine a violin where it just sustains, the more you can pinpoint its identity. That's a C, I can tell. Well, what happens if we start to really speed that up? And you see there a pattern at the top, a rhythmic pattern that speeds up faster and faster. Well, the identity seems to disappear, doesn't it? You can't really tell what that note is. And the faster it goes, the more complicated it gets, the less identity we know. Metaphorically, we're experiencing a quantum principle in the music. And so when we listen tonight, that will be expressed through the music. There will be this quantum metaphorical wave function that is taking place. So it's uncertainty principle metaphorically represented in music. On the bottom, we see a wave function, same as the previous picture. In this case, it's not the position of an electron, it's the position of a note. Some notes are more probable than others. They exist in the center. Some notes are less probable than others. It exists on the sides. But all notes are possible. Maybe not probable, but possible. If I have a repeating pattern of the same notes, C, D, F, G, C, D, F, G, C, D, F, G, chances are one of those notes will be in the next pattern. But there's always a chance a G sharp finds its way in there, or some non-probable note. Possible, not probable. Let's talk about the visuals you'll be experiencing tonight. As I play, there will be a video art installation behind me. The imagery you see will all be abstracted. And this imagery is of real things out there in the world. There's no Photoshop, there's no digital manipulation with the imagery. It's all the world out there from New York to Tokyo. And you see on the left here a picture from downtown Manhattan, Manhattan mini storage. You've all driven by it a million times if you've been to New York. The picture on the right was taken seconds later of the same sign. Seconds later of the same sign, using light and movement. What did we just talk about? Speed of light, movement. And so, again, this is visually a way to shift our perception, to offer and say, there's another way to see things. In the same way that the music says there's another way to hear things. Yogic tradition, yogic wisdom teaches us that there's a level of perception, they call it samadhi, in In yoga, there's about 8 levels, 8 limbs, 8 steps in yogic pursuit. And samadhi is this 8th level, highest level of achievement of consciousness. And after meditation, there's this notion that there's an absorption, possibly. An absorption of what? Absorption of consciousness. This notion of non-dual awareness. What does that mean? We talk about non-dual awareness. Awareness of what? Duality of what? Well, in awareness and perception, all of us experience 2 things. Subject and object. Come on in. Welcome. Hi. Talk about uncertainty principle. Yes. That was amazing. Yeah. By the way, probable? No. Possible? Yes. That was amazing. Thank you, Alan. Thank you for illustrating my point. Please go ahead. Go ahead. Please sit. Right here.
I can play chopsticks for you later.
That was awesome. Possible, not probable. By the way, on a quantum level, by the way, you don't need this, I think, because you can totally get what I'm talking about.
Like the embodiment of chaos theory, right?
That's what you know who I think here. On a quantum level, any one of us, at any moment, can be far flung to the far side of the universe. True statement. Very unlikely. Why? Because every single subatomic particle in our bodies would have to conspire at the same exact moment to decide to do that. And there's countless trillions of them, and therefore the math of that is totally unlikely. But it could happen given enough time. The universe is not that old, 13.7 billion years old, but if it were trillions of years old, somebody would happen to somebody at some point. Anyway, just an aside, given that amazing thing. So we're talking about absorption, non-dual awareness. There's a notion of a subject, me, I'm the subject, observing an object. The object could be this piano, this object could be a wall, the light, you, the audience, and we're all experiencing that here from totally different frames, right? We're all subject and object relationship. And what they teach us is there's an opportunity to collapse that, where the subject and the object collapse into one sense of being. Wow. That's a very powerful conception. It's a very powerful conception. But what happens at that point? What is available at that point? Well, what they talk about is this idea of mukti, or moksha. And that is essentially this place of nothingness. There's nothing there, because there's no one observing, and there's no one being observed in this collapsing, in this absorption. And what's possible in that space is pure creativity. What's possible in that space where there's nothing is anything you want to put in there. Somebody earlier mentioned they want to tap into creativity. This is the way to tap into creativity, by getting rid of everything that's on there and then allowing something new to emerge. Before we start, I'll leave you with one final thought. When I start playing, there's a certain image I have in my mind. That image is of placing a leaf into a river. The river acts as metaphor for time, for the journey we all experience. There clearly is a sense of past, present, and future. The river flowing. We even say time flows. The arrow of time. Time is moving. There's a flowingness to it. And water and river seem to encapsulate that metaphor. But Einstein told us that the past, present, and future are all illusions, albeit persistent ones. So how am I supposed to think about that? How am I supposed to think about the river, the past, present, and future? It seems very real. I experience every day. Certainly seems to confirm that. How am I supposed to think about that? What did he mean? Well, what he meant was there's no separation between the two, that all of them exist simultaneously. And a French philosopher us, is the witness to time. That without this leaf, there would be no perception of time. Wow. If we think about this notion of absorption we just talked about, then is the leaf really there? Unclear. There's no observing the leaf. And so what does time feel like in that particular level of awareness? We also said that in order for something to collapse as wave function in quantum physics, it must be observed. There has to be an observer present. Seems awfully similar to what the yogis were talking about for 3,000 years, doesn't it? So without an observation, the particle exists everywhere. All possibilities exist. With the leaf there, it's very clear there's one sense of identity, there's what is. So I leave it to you of what's available from a quantum point of view, from a samadhi point of view. All of it revolves around observation and consciousness. I find that absolutely aspirational, personally, and something that I not only think about, but pursue, and primarily pursue through the music.